Hi, the grade 10s. Now I'm going to do the evaluation. I'm going to do it live as well. Hopefully, it all works out. So here's from the lab guide. Evaluate the method. Evaluate the validity of the method based on the outcome of the scientific investigation. So it's not about did I have the right number of steps. It's whether the instrument measures what it's supposed to measure, the conditions of the experiment, and the minimum of fair testing. Suitable range, number of measurements, dependent variable. So let's check out these things here. We don't do all of them, but let's see what fits. I started a little bit and then I decided to record this video. We'll see how it goes. So pretty much looking at the results, we get what we expected. So I think the experiment is valid. At the same point, all of this data here is about the same. So this may even be like background noise that's being measured. I'm not sure. It's about the same. So we don't really need all of that data. I imagine if we had more data in here, it might be better. So I'm going to say that the experiment is valid, but in terms of the range, from 1.75 meters to 4 meters, the data is about the same. So I'm going to suggest that maybe we should get more data points inside here in finer steps to help us get the shape on this curve better, because we got that one dot there, so we could get some better data. Okay, so all the results from 1.75 meters to 4 meters are very similar. So that's one problem. Again, explain improvements and extensions. So we could have a separate paragraph, or I can put that right here. I would put it right here. Or maybe over here, we'll see. The issue of several data points the same from after 1.75 meters can be improved by reducing the range and having more data points during the first 1 meter of measurements. Okay. Check the lab guide again. Control variables are fine. The data was reliable. Greatest source of uncertainty. There's an extension we could have done to find the uncertainty for sound for the average, but we didn't do that. All of those things are fine. The data was precise since 5 Fox. Data to 6 decimal places. So it's precise. Is it reliable? This honestly, the data is not as reliable as I would like. At the lower end, the higher end is not so bad. But the average is all about there. Look at that, guys. 500, 800, 300, 3, 5, 4, 1, 4. The data is fairly reliable, but I actually think more trials should be taken since there is a range in the data. This is where if you did the optional extension to find the uncertainty for repeated trials, you could actually say something better than what I can say now. That's where doing extra work makes your life easier. More trials is kind of vague. I'm going to say 5 trials. That's what we do in DP. Since there is a range in the data recorded. Explain. I need to give the reason. Let's give a reason here. The first 1 meter is where more of the change happens on the graph, so more data would enhance the curve, would increase the reliability of the inverse relationship. So I give a reason there. Extensions. One extension to this experiment would be to see. So what could I change about this experiment? Maybe thickness. You're thinking about soundproofing things. This is a real life issue. Instead of having distance, maybe thickness of materials. If different thicknesses of materials, see the relation between different thickness of materials and sound amplitude. I need to explain this. This is a real life application as knowing what thickness of material should be used to reduce sound volume. That's pretty good. I have an extension. I have an improvement here. I have another improvement because of the reliability is a bit low. I think that's reasonable. Hopefully that helps.